How does trial division find prime numbers? Imagine trying to find out if a number is prime or not. It's like checking if a number has any hidden factors that can divide it evenly. That's where trial division comes into play. It's one of the simplest ways to test if a number is prime by seeing if any smaller numbers can divide it without leaving a remainder. The process starts with the idea that a prime number is a whole number greater than one that can only be divided evenly by one and itself. To test this, you begin by dividing the number by 2. If 2 divides it evenly, then the number is not prime because it has a smaller divisor. If not, you move on to the next number, which is 3, then 4, and so on. But here's a key point. You don't need to check all the way up to the number itself. Instead, you only need to check up to the square root of the number. For example, if you want to test if a number like 121 is prime, you only need to check divisibility up to 11 because the square root of 121 is about 11.05. If no number less than or equal to 11 divides it evenly, then the number is prime. This saves a lot of time because checking every number up to 121 would be unnecessary. Another trick is to only test prime numbers as potential divisors. Why? Because if a number is divisible by a composite number, it's also divisible by the prime factors of that composite number. So, testing only prime divisors reduces the number of checks needed. For example, if a number is divisible by 6, it's also divisible by 2 and 3, which are prime. The steps are simple. Take your number, check if it's divisible by 2, then 3, then 5, and so on, up to the square root of your number. If any of these divides it evenly, the number is not prime. If none do, then it's a prime number. This method ties into basic number theory because prime numbers are the building blocks of all natural numbers. They can't be broken down further, which makes them special in mathematics. Trial division is especially useful for small numbers or as a first step in more complex factorization methods. It helps reveal the hidden structure of numbers and shows how primes stand apart as indivisible units. It's a simple yet powerful way to understand the fundamental nature of numbers and their meanings.